Hello and welcome to another video on the MAT 2014. This time I'm doing the short questions F to J. Okay, here we go. I quite liked actually most of these. They weren't too bad. There was one or two which confused me a bit, but they weren't too bad. Okay, so we've got a function. They love these little functions in the mat where you're just adding one or doubling or timesing by -1, that kind of thing. They can make fiendishly difficult questions out of the simplest functions. But the reason they're difficult is because we apply these functions in some kind of order, in some order. And they're going to make 8 minus x here. Now, I quite like this one. This didn't take me too long because I kind of thought, well, okay, if you're building f from s and t, we're kind of building that function. Well, straight away, t must be applied an odd number of times, yeah? Looking at what the answers are about, it's about how many times they're applied, yeah? Well, you've got to apply t an odd number of times because if you apply it once, you get minus x, yeah? You know, in other words, if you just start with x and you apply t, so you've got t of x, you've got minus x. So applying it once is minus x. Applying it twice is positive x. That's not f. Applying it 3 times is negative x. Applying it 4 times is positive x. S isn't ever going to be able to change the sign because it just puts plonks a +1 on the end of whatever you've got there. And so this must be applied an odd number of times, yeah? It's as simple as that. We don't know how many times, but it must be applied an odd number of times. That can't be disputed. Now, you might be tempted to say, okay, well, we've got to get to 8 as well, so S has got to be applied 8 times. Well, it's certainly true that that is a way of getting from these two to F. You could apply T and then S 8 times. And then, you know, in other words, S, if I can use this notation, S8T of X, that is definitely going to equal F of X, isn't it? Because you're going to go from X to minus X, and then you're going to add 1, 1, 1, 1, 1, 1, 1, 1, and you're going to get minus X plus 8, which is the same thing. But there's other ways of getting to F. For example, I mean, I straight away just noticed certainly powers of 2. No, no. And this, no. I mean, no, just no. Because we can do it in another way. We could, for example, add 10 times S. Yeah, we could do S 10 times to X. Yeah, and obviously that's X plus 10. Yeah, but then we could apply t. So we've got t s of 10 of x, and that's going to be minus x minus 10. And now we can get back. Oh, mine, I wrote plus, but I said minus. I do this in class a lot as well. And then I could apply s, say 18 times. So I've got S18t, S10 of x. This was just what occurred to me when I was doing this question. And that would give me f of x, yeah? And so it's like, well, there's loads of ways of building f of x out of this then. And clearly, we need to apply s an even number of times, yeah? Because we've got an even number here. There's loads of ways of building 8, but if we apply s an odd number of times, we're going to have added 1 an odd number of times, and you're just not going to get to the value of 8 from that. And so the answer is quite clearly s is odd. S is even and t is odd. So the answer is C here. So that one wasn't too bad. The other answers just don't look. I mean, that's definitely wrong. That's nonsense. And you know, I've just shown you that that's not true. Powers of 2. What's this got to do with powers of 2? No way. None of the above. No, no. No. It's definitely got to be applied an even number of times. S. Okay, so G. This one I thought was a bit harder, but I mean, that said, um, I've seen these kind of ones before. I mean, straight away you might be thinking, okay, 3 terms and an expansion, that's trinomial. Do you know any trinomial coefficients? Do you know trinomial theorem? No, so we need to make this binomial by making it, you know, just 2 terms. And, you know, best way to think about that is, right, as 1 plus, now I did factorize this just because I thought it would probably make things easier. I'm not sure if it does or not really, but I thought of it as that term plus that term all to the power of n. Yeah, and I'm trying to make quite a big number here, but this, think of it as a 1 plus rather than thinking of it as 1 plus xy and y squared and using like a plus b to the n. I think this makes it slightly easier because we can use the formula where we do like 1 plus n times by y plus xy. Now clearly that's not what we're looking for, is it? Plus n times n minus 1 over 2 y squared times x plus y squared. But let's write that as n choose 2. I'm a big fan of this notation. It obviously doesn't matter. It's just notation. But I'm going to write n choose 2 rather than the vectors. But that's fine. You know, whatever you prefer. X squared x plus y all squared. Now just have a little think here. Have you got to the point where you're going to get y is 5 out of that? No, y to the 5, no way, this is y to the 4. So you're going to have to go further. N choose 3, we're going to have like y cubed, x plus y cubed. Now this actually lets us down, but it's not obvious why at this stage, I think. And then, you know what these expansions are like, they're long. N choose 4, I'm going to write it down like up to like y to the 5, because clearly, well, actually just y to the 4 will do, but and I'll argue why in a second. X plus y to the 4. Now, if you were to write down n choose 5, y to the 5, hopefully you can see straight away, hang on a second, you know, I'm going to get y to the 5 times by x to the 5 there. That's not going to give me a y to the 5x cubed, is it? And every other term is going to have a y in there, which makes that y to the 6. So that's no good. Yeah. And actually, we've already decided that's no good, and that's no good. So the candidates are these two. This is the way I saw it anyway. But look at n choose 3. You're going to get like times y cubed. And I'm just looking for the y5x cubed here. Well, I know the expansion for cube because you can just use Pythagoras' theorem. What am I talking about? Binomial, Pascal's triangle. That's what I meant. Pascal's triangle, x cubed plus 3x squared y plus 3xy squared plus y cubed. Yeah, and this is just for this term here. Well, can you see here? You're going to get a y cubed times by a y squared. Well, that's great. You've got y to the 5, but then you've only got x on that. So that's no good. And every other term is going to not give you the right power on the y. So that's also, I'm afraid, no go, no joy. You might start getting depressed here and thinking, oh, I'm doing the question wrong. But no, the candidate is right here. So we need n choose 4. But what we need to do is a quick bit of Pascal's triangle on this. X to the 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4. Yeah, and now have a look at this and find where you're going to get your x cubed y to the 5. Where you're going to get this. Where you're going to get it? Well, you're going to get it from y to the 4 times y. Here it is. We've finally found the individual we need. So the answer is n choose 4 times by 4. Yeah, there it is. There it is. And so the answer is D. Done. So that's just like handling a lot of like, you know, a difficult expansion. H, this was the one which I probably didn't like the most, you know, as I found most difficult. It's a good question. It's a really cute question, but it confused me the most. Mainly because I was thinking of prime factor decomposition might help or something like that, because I didn't really look carefully at this, and I didn't start at the right end. I started at 6,000 and thought it might be somehow possible to kind of go down. Like, no, 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 no. That is definitely the wrong way to do this question. If you start from f of 1 equals 0, which I, you know, eventually twigged after faffing about and wasting time. And that's the thing. Don't think I would have got this right in test conditions. I think I would have ended up giving up after 5 minutes and moving on to I, which is ridiculously easy if you ask me. But okay, so f of 1 is 0. F of 2, you know, we're just going to try and get the pattern here. F of 2, we're going to get f of 2. Well, that's divisible by 2. It divides 2, but 3 does not divide 2. So we need to take our last one, which is this 0, and add 2 to it. F of 3, well, we're now on this one, so we need to take the last one, which is 2, and add 3 to it, so that's 5. F of 4, well, we're back to this one now, and so because it's divisible by 2, we only need to add 2 to it. F of 5, you can do this really quick as well, that's the nice thing. That's neither divisible by 2 nor 3, so we need to add 4 to it. And F of 6, sorry, did I just say that's neither yeah. That's yeah, did I get yeah. I think I said it wrong, but I did it right, if you see what I mean. So I either say it right and do it wrong, or say it wrong and do it right. So I apologize. I talk too quickly and it doesn't help me. So f of 5, well, 5 is neither 2 nor 3 divides 5, and so we're actually still stuck on 7 here. Yeah, because f of n equals f of n minus 1. And then f of 6, well, both those divide n. And so we're going to add 4 here, and we get to 11. Now, just think carefully now. What is going to happen as we proceed here? We're going to go through exactly the same routine, because for every 6 numbers, you're going to get the next one is not divisible by 2 or 3. The one after that's going to be divisible by 2. The one after that's going to be divisible by 3. The one after that's going to be divisible by 2. Then it's not going to be divisible by anything, and then it's going to be divisible by 6. You're going to go through exactly the same routine. If you don't believe me, actually work it through, and you'll see that you get exactly the same routine. You're hopping to exactly the same statements each time, and that's what's important. I'm just writing these down, and then I'm just going to write down the values, but I fully invite you to check them. Basically, you're going to get, again, 11, 13, 16, 18, 18, 22. Yeah. No, when you have them next to each other like this, you can see the same things happening. We're jumping 2, then we're jumping 3, then we're jumping 2, then we're not jumping at all, then we're jumping 4. Yeah. Same thing's going to happen every time. Now look at this. You know, take it to f of 18 if you like, and you'll see 11 here, 22 here, 33 on f of 18. In other words, you can then just kind of guess the formula, can't you? That basically, if you're doing f of 6k, that's going to equal 11 times k every single time. That's why f of 12, well, k is 2 there, 2 times 11, 22. And so f of 6,000, obviously that's f of 1,000, f of 6 times 1,000, so k is 1,000. So all we've got to do is 11 times 1,000, which is 11,000. When you see the answer as one of the possibilities, and there's so many other random ones, you know you've got it right. Okay, this one, I wouldn't have been disappointed if this one was A. I really wouldn't. I like, because this is typical. It really is. Firstly, we just, there's two things you can do with a quadratic, really, aren't there? Like, you can factorize it or you can complete the square. I think they've deliberately written one which factorizes. The reason why I'm thinking complete the square here is because this is about function transformations, yeah? And what is so nice about completed square form is that it represents a quadratic as a function transformation of how you get from x squared to x minus 1 squared plus 3. Well, naturally, we need to move it 1 to the right and 3 up. Yeah, that's why that one's got a minimum. It's another reason why it's got a minimum at 1, 3. I mean, there's many other ways you can explain why that generates a minimum of 1, 3. But a nice way would be just saying, it's x squared, move 1 across, 3 up. And that's why I immediately thought, complete the squares. This is about function transformations. And especially because we're going from 2 to the x squared to 2 to the x squared minus 4x plus 3. This is just quadratic function transformations. So, yeah. 2 to the, what is that going to be? X minus 1 squared. We need to get from minus 1, therefore, to plus 3. So we need a plus 4 on the end. And so I'm just going to write that down. What am I talking about? We need a minus 1 on the end. God, I can't even complete the square today. It's let me just write this down. Sorry, I'm in a terrible state. Let's do this properly. X squared minus 4x plus 3. We're going to complete the square. X minus 2 squared, because I've got x minus 1 written down there, it's massively putting me off. I need to take away 4, and then I've got a plus 3, so I'm going to have a minus 1 there. There we go. I can complete the square. I promise you. Okay, so here we go. X minus 2 squared minus 1. Okay, so immediately my thoughts were, so it's moved 2 across and 1 down. But none of those answers are there. Yeah, they've got like it's a translation parallel to x followed by a stretch parallel to y, and they've got a translation parallel to x followed by a stretch parallel to x, and they've got a translation parallel to x followed by a reflection in the y. So they've got all of those, but I was like, well, it's going to be one of those three. But of course, you can just rearrange this, can't you, to y equals 2 to the x minus 2 squared multiplied by 2 to the minus 1, which is the same as timesing by a half. And that's a stretch. And that's why this is B. Yeah? And that's how you get this answer. Apologies for my awful attempt to complete the square there. It's because I'm looking at that. I can't have too many equations in front of my eyes. Okay, Jay. Okay, I'm like, if you struggled on this one, I hope to give you a nice way of thinking about this. I hope so, anyway. I remember the first time I looked at this going back about 3 or 4 years ago. I remember looking at this and just thinking, wow, this is baffling. But I had a go at it, and it's always an advantage when you're doing it in hindsight again. And I found what I think is quite a nice way of looking at it. Anyway, firstly, you should realise whenever you've got your equations, think about what's a variable, what's a constant, what's just a number. That is just a number. I don't know what f of x is. I really don't. But if I'm integrating it between two values, that kicks out a value, doesn't it? It kicks out a number. So that is a number. So let's call it a number. Let's say let k, because I don't want to keep writing that down. It's a pain in the bum. Equal 1 to minus 1 f of t dt. Yeah? And obviously, by the way, that's what we're trying to find as well, yeah? It does not matter what variable you put in there, like if it's a function being applied to it and there's only one variable in the function. That is exactly the same answer as f of x dx. Let me say that straight away. It's the same thing. Who cares what letter we're using to represent our variable in that integral? But this is a constant, yeah? And so what have we got? 6 plus f of x equals 2f of minus x plus 3x squared k. Yeah, cool. Okay, now it looks a little less intimidating now, but this is still a hard question. But the fact that they've got f of x here and 2f of minus x here makes me think, well, firstly, let's just kick that. It's annoying having that 6 over there. I'm just going to move that over. I'm going to look at what f of minus x is, because, you know, clearly this is about x and minus x, so maybe the question is about x and minus x. So obviously I'm trading all my x's for minus x's, so that becomes a plus x, a positive x. Now, when you square a minus x, it's just x squared still, isn't it? So this is 3x squared k minus 6. Okay, that's kind of nice. What we can now do, of course, is we can eliminate f of minus x. I'm just trying to eliminate f of minus x here. I'm going to basically plug all of this in there. I hope you see where my arrow's going there. Like, I'm going to plug all of that in there. So f of x is 2 times by 2f of x plus 3x squared k minus 6. That's plugged it all into there. And then I've got a plus 3x squared k minus 6. And let's simplify that. So I've got f of x equals 4f of x. Then I'm going to have 6x squared k plus a 3x squared k. Well, that's plus 9x squared k. And then I've got a minus 12 minus 6. That's minus 18. Yeah. Now, just a little bit of rearrangement. Take this over here. You're going to have minus 3f of x. Divide it all by minus 3. You're eventually going to get f of x equals, now we're going to need to divide these by 3 and change the sign. So that's 6 minus 3x squared k. Look at that. Just have a look at that. What we've shown is that f of x is a quadratic. That's it. It's a quadratic. Like, when you get to that point, it's a massive kind of like, okay, like this I think we've got a toehold on the, you know, the wall that we're climbing here, which is the problem. What I'm going to do now is I'm going to integrate both sides with respect to x between the limits of 1 and minus 1. So the left-hand side should equal the right-hand side integrated between the limits of 1 and minus 1, 3x squared k, with respect to x. Yeah, and you might think, what are you doing? Well, I'm just integrating both sides with respect to x between 1 and minus 1. Now what I can do, well, firstly, as noted earlier, that there is just k. This can be directly integrated, 6x minus x cubed k between the limits of 1 and minus 1. And now off we go to the answer, basically, because k equals, we're going to get 6 minus k minus 6. Now be careful here, minus 1 cubed is minus 1. That's going to become a plus k. And so what do we got here? We've got 6 minus minus 6, which is 12, minus k, which is minus 2k. Add it over. K is 4. And k is what we're trying to find, remember, because k is that. And so the answer is A. I can't remember how I did it 4 years ago. I think I made an argument about even functions and integration. I massively prefer this way. I'm not really appealing to even functions. I'm just really using the principle of substitution, which I quite like. So yeah, hope you like that method of doing it. I was quite pleased when I did it like that this morning. It's like, yeah, that's definitely the way to go about with this one. Okay, so yeah, hope you enjoyed the video. Hope it was useful anyway. And yeah, good luck in the map. Bye bye.